After the study of atomic spectra for a hydrogen atom, scientist Niels Bohr came up with Bohr's model of atom. Along with hydrogen atom, he also studied the atomic spectra for the other elements. But since hydrogen is the simplest of all, with just one electron and one proton, he stated the model of atom for hydrogen. So here are the postulates for Bohr's model for hydrogen atom. First, an electron in an atom revolves around the nucleus only in certain fixed circular orbits. Electron revolves around the nucleus in a fixed circular orbits. These orbits have definite energies and are also called energy shells or energy levels. These are numbered as 1, 2, 3, 4 or designated the letters like K, L, M, N, and it continues. Second postulate states that only those orbits are permitted in which the angular momentum, that is, the product of mass, velocity, and radius of the electron is an integral multiple of h by 2 pi. H is the Planck's constant. That is, we can write the equation as mvr equal to nh divided by 2 pi, where n stands for the number of the energy shell. So for the first energy level, it will be 1 multiplied by h by 2 pi. For the second one, it will be 2 multiplied by h by 2 pi. Hence, the angular momentum of the electron in that particular orbit will be fixed value. Bohr's third postulate for the model of atom states that energy of an electron in a particular orbit remains constant. That is why these orbits are called stationary states, since that energy level is same. According to the fourth postulate, when energy from some external source is supplied to the electron, it may jump to some high energy level by absorbing a definite amount of energy. When electron jumps back to the lower energy level, it radiates the same amount of energy in the form of radiation. Let me make it again clear to you. It says that electron in a stationary state at a particular energy level can absorb the energy, go to the excited state by gaining the energy, thus lose the energy and come back to the ground state. This loss of energy occurs in a form of radiation. This can be given as delta E. The change in the energy is equal to E2 minus E1. E2 is the excited state of the electron and the energy related to that, and E1 is the energy of an electron in a ground state, and this is equal to h nu. Because we always mention that E is equal to h nu, we give it as a product of Planck's constant and that of the frequency of radiation. Now, here are the four postulates of Bohr's model of atom. Although there was lot of a clarity which was given with respect to the structure of atom by Niels Bohr, still there were some drawbacks, limitations which were observed. These limitations are as follows. First, it could not explain the spectra of an atom containing more than one electron. That means Bohr's model of an atom was much restricted to the very simple system of that of a hydrogen atom. The moment the relations of the postulates were correlated to that of helium spectra, or that of lithium, or that I would say a multi-electron system, it could not explain the postulates which were observed. Secondly, it could not explain the fine structure of a hydrogen spectrum, because when hydrogen spectra was studied under a high resolution spectroscope, there were few more lines which were observed, and this could not be explained by the Bohr. The third one is that it could not explain Zeeman effect or that of Stark effect. This is splitting of the spectral lines in presence of a magnetic field and electric field respectively. As to why the presence of a magnetic field and that of an electric field is interfering with the atomic spectra of an atom. And lastly, Bohr model could not explain the ability of an atom to form molecules by chemical bonding. That means when it is saying that electron is present in a certain orbit, it has a particular amount of energy, it is moving with a certain angular momentum. How is that the two atoms will combine and form a molecule? So this was not been able, Niels Bohr was unable to explain the same.